Hello friends, so this is again the follow-up of my previous video on test beam sensor characterization, and this picture is from this particular publication in 2025. Here basically we characterize the DUT, detector under test, which is basically APTS op-amp. This is a sensor type, analog pixel test structure op-amp sensor. So we would like to extract the spatial resolution of this sensor, and the formula for the spatial resolution is given below. Sigma of spatial resolution square is equals to sigma of residual square at this plane and minus of sigma of tracking square at this plane. So once we know the sigma of residual and sigma tracking, we can also extract from the fitted tracks or from the telescope simulation software. So here basically we perform the analysis using the calibration software, all the steps like pre-alignment and then alignment. After the alignment, we perform the tracking. Here we use the 7 planes for the tracking: 0, 1, 2, 4, 5, 6, 7. So basically we excluded the DUT from the tracking so that we have the unbiased residuals from the track fitted and the hit position at this plane. So we evaluate the residuals between the fitted tracks and the hit position at this plane, and we take the sigma of this residuals distribution, and then we also estimate the tracking resolution using the, let's say, telescope simulation. And we can also extract this tracking resolution from each fitted tracks using the calibration software. That also so the software also provide the tracking resolution for each fitted track. So now you have the sigma of residuals at this plane and then the sigma of tracking. Then we can estimate the sigma of spatial resolution of this particular sensor, and this we estimate in this particular publication. We estimated at different detector threshold. So when you apply certain threshold, how this your spatial resolution varies with the detector threshold. That's what we quoted in this publication. Now I will also explain how do we extract this tracking resolution. We can extract this using the telescope simulation. This particular setup is also known as the telescope in test beam data analysis. As I already mentioned, that we have to extract the tracking resolution at the DUT plane. So for this we need to use the telescope simulation software. So this is the software. You can simulate the telescope telescope setup here. So here basically I define the same setup shown in the image. So you can see the 7 layers in the tracking, and you can see the positions also. Here I assume that the DUT at position 0, then basically I created all the layers, and then also I defined the spatial resolution for each layer and then also the material budget for each layer. Then it basically estimate the tracking resolution at this plane, at the DUT plane. So here basically it shows the tracking resolution is 1.89 micrometer, is around 1.9 micrometer at the DUT plane. So this tracking resolution we can use in the formula, and then we estimate the spatial resolution of the DUT, which is basically APTS, analog pixel test structure op-amp. So if you would like to play with it, you can also play with it. So if you change, for example, if you change the position of this, then it will change. You can see that. So you can basically extract the tracking resolution using this particular tracking telescope simulation software.